We have three different points, A, B, and C, all lying in the same xy plane, and then we're told that O is the origin. So the first question is to show that A, B, and C are collinear. So let's just start off by writing the different vectors. So the position vector of A, well, all of these position vectors are just going to be the coordinates but written in vector form. So -1, 4. So to show that these 3 points are collinear, we have to pick any two unique pairs of points out of these 3. So for instance, I could pick A to B, that's one pair, and another pair could be B to C. And then I want to work out what these two vectors are, and they should be parallel to one another. So whenever you have two vectors that take us from one point to another, and they're parallel, that means they will be scalar multiples of one another. That's all we're going to show. So if they're scalar multiples of each other, if they're parallel, and if they share a point in common, which in this case would be B, then they must be collinear. They must be all on the same straight line. So let's start with AB. AB is equal to A to O plus O to B, which is, so A to O is the negative of O to A, so 1 minus 4. O to B is 2, 3. So this will then be 3 minus 1. And then for BC, similar kind of thing. We can go from B to O, and then O to C, which will be the negative of OB, minus 2 minus 3, plus OC, 8, 1. So then B to C is 6 minus 2. And if you look at these two vectors, we can see that B to C is 2 lots of A to B. Therefore, they are scalar multiples of each other. That means they're parallel. And because they share point B in common, then points A, B, and C must be collinear. Okay, so on to part B. So we're told that D lies on BC such that B to D to B to C is in the ratio of 2 to 3. Okay, so B to D to B to C is in the ratio of 2 to 3. That means that the length of BD over the length of BC is 2 over 3. And we can write this as the vector BD is equal to 2/3 of BC. We're trying to work out the coordinates of D, so let's try and work out what the position vector of D would be. Let's go from O to D. We'll try and use the information that we have here. So we can go, if we have what BD is, we can go from O to B, and then from B to D, and that will give us OD. So to work out B to D, we need to work out what 2/3 of BC is. We have BC over here, so therefore BD is 2/3 of 6 minus 2, which is the same thing as, so 2/3 times 6 would be 4, and then 2/3 times minus 2 would be minus 4 over 3. So that's BD. So then OD is OB, which is what we have right at the top, 2, 3, plus BD, which is 4 minus 4 over 3. And this will then be 6, 5 over 3. So the question is asking us for a coordinate instead of a position vector. So then we convert this to a coordinate. So the coordinate of D will then be 6, 5 over 3. And now for the last part, for part C. So we are told that the straight line OB is extended to point P such that AP is parallel to OC. Determine the coordinates of P. So let's try and sketch this out. I'm not going to worry about the coordinates I'm just going to try and sketch this out based off this information. So we're told that AP is parallel to OC. So let's just draw that. So let's say that this is A, this is P, and let's say that this here is O, and this is C. So these two things are parallel as mentioned in the question. And so the coordinate P we get by extending the straight line OB that takes us to P. So then that would mean that B is somewhere along this line. So B is, let's say, here, and then we've extended the line from O to B to get to point P. So not to scale, again, I've not considered where the actual points are. We can represent it like this, and this should be enough to help us work out our answer. So we're trying to work out the coordinates of P. So if we're trying to work out the coordinates of P, we want to work out the position vector of P to start with. So how can we do that? Well, we know that AP is parallel to OC, therefore AP is a scalar multiple of OC. We know that the point B, or rather the vector from O to B, has been extended to get us to P. So that would mean that O to P is a scalar multiple of O to B, some other scalar multiple, so it doesn't have to be the same as what we have here. So whenever we have scenarios like this, where we have two different scalar multiples, how we want to then work out what the scalar multiples are is to take two different paths between the same 2 points. Equate the vectors you get for those two different paths, and then solve simultaneously for mu and lambda. So that might be a bit confusing, so let's show this on the diagram. Let's see what we have so far. So we have O to P. O to P is this. And then we have what A to P is. A to P is this. So if we were to go from, we have what O to P is. If we were to take another route from O to P, if we were to go from O to A, and then A to P, so this particular route of OP is OA plus AP. This is another path that takes us from O to P, in contrast to the direct orange path that takes us there. The blue path, we can write this in terms of lambda, because A to P is just lambda OC. So we have blue path takes us through one route from O to P, and that involves lambda. Orange path takes us directly from O to P, and that involves mu. So those two things should be equal. We set them equal to one another, and then we can solve simultaneously to work out what mu or lambda is. Okay, so let's first work out what they are. So O to P, blue path, is O to A. O to A was minus 1, 4. So minus 1, 4, and then plus lambda OC, so plus lambda times OC, which is 8, 1. So this will be minus 1 plus 8 lambda, 4 plus lambda. Orange OP, that's just mu OB. OB was 2, 3. So then this will be mu times 2, 3, or 2 mu, 3 mu. And these two will be equal to one another. They're both taking us from O to P, so we can equate them. So we get minus 1 plus 8 lambda, so this is the blue path, is equal to the orange path, 2 mu, 3 mu. So considering the I components, we get minus 1 plus 8 lambda is 2 mu, and considering the j components, we get 4 plus lambda is 3 mu. We want to solve these simultaneously, so I'll rearrange this for lambda. Lambda is 3 mu minus 4, and then I'll sub that in to here. So that becomes minus 1 plus 8 lambda, which is this, 3 mu minus 4 is equal to 2 mu. Expand out the left-hand side. And then I'm going to simplify this. So I'll bring the 2 mu to the left-hand side. We get 22 mu. And I'll bring the minus 32 and minus 1 to the other side. That's minus 33. When you bring it to the right-hand side, it'll be positive 33. And then we get mu is 33 over 22, or 3 over 2. So now that we have mu, we can work out what OP is using this vector. So we're timesing mu by 2, 3. So then OP is 3 over 2 multiplied by 2, 3. So these two times together will give 3. These two times together will give 9 over 2. And that is our answer. So our coordinate, so this was our position vector, our coordinate will then be 3, 9 over 2.